Hey everyone, Mrs. Anhire here. I'm going to give you a little lesson on electric fields. This is what electric fields look like. Electric fields are the arrows that are going from positive to negative charge. And anything carrying a net charge will have an electric field around it. The electric field is a region in space where a force is exerted on a positive test charge, and the larger the charge, the larger the electric field around it. So this is very similar to a gravitational field. We learned about gravitational fields which surround large bodies such as planets. We did do a project where we took a foam ball and stuck a bunch of different toothpicks into it to represent the gravitational field around large planets, and we pointed out that the closer together those toothpicks were, the greater the gravitational field. The further away the toothpicks got, as it got further away from the planet, the force in the gravitational field got smaller and smaller. So that is very similar to how electric fields act. So if I have an unknown charge in this sphere right here, I can figure out what charge it is if I have a positive test charge. So as you guys learned, if the positive test charge were to repel from the sphere, we know the sphere is positively charged. If it were to attract, then we know it would be a negatively charged sphere. So that's one of the ways that you're able to test charges of objects. Now, electric field drawings are represented by vectors. The closer together the lines are, the stronger the field, as we demonstrated in gravitational force fields. And the electric field lines are shown as leaving a positive field and going towards a negative field. So this is the direction in which your positive test charge would flow. It would flow along these arrows depending on what position it is in this electric field. So we're always representing these arrows as the direction of a positive test charge because positives repel positive charges. The force from this field depends on the size of the charges and the distance between them, which is basically Coulomb's law. So electric fields are electric lines of force. They represent the direction that a positive test charge would move in an electric field. The electric field lines do not actually exist, but the field does, and the lines are merely representations of that field. So here we've got some examples of some electric fields. When I have a positive and a negative charge, then the electric field would look like this. And if I had a positive test charge here, they would travel toward the negative charge. If I had two positive charges, this is what the electric field lines would look like. And if I had a positive charge, wherever it was at, it would move in the direction of these electric field lines away from the positive charge. Hope this helps with your Flipgrid assignment when you start playing electric field hockey. Good luck.